Good day. In this lecture, we will discuss how to calculate the energy generated from a battery, linking electrochemistry with the basic electrical concepts. By the end of this lecture, you should be able to solve for the energy produced by a battery using its voltage and capacity. Let's begin with alkaline batteries. These batteries typically have a voltage of 1.5 volts regardless of the size, from the AAA batteries to the D cells. However, while voltage is the same, their capacity differs. Capacity refers to how long the battery can supply the current. For example, the AAA has about 540 milliampere hours, the AA has about 1,100 milliampere hours, and the Type C cells has about 3,800 milliampere hours. So larger batteries can last longer because they contain more reactive material. Now, the capacity is measured in milliampere hours or mAh. This tells us how much charge a battery can deliver over time. A higher capacity means that the battery can sustain electron flow for a longer duration, not that it produces higher voltage. To calculate the energy, we relate the current, the voltage, the power, and the time. Power is equal to the current multiplied by the voltage, and energy is power multiplied by the time. So overall, energy depends on how much the current flows, the voltage, and how long the battery operates. In terms of important unit relationship, 1 joule equals 1 volt times coulomb. 1 ampere equals 1 coulomb per second. Therefore, energy can also be written as volt times ampere times time. And these relationships allows us to convert battery capacity into energy. To calculate the energy from battery capacity, we have to convert first the milliampere hour into ampere seconds, then multiply by the battery voltage, and this gives energy in joules. This step is critical because capacity is not directly related to the energy. It must be converted. An example here is a AA battery. It has 1.5 volts and 1,100 milliampere hours. First, convert the 1,100 milliampere hours to ampere hours, then to seconds. After the conversion, multiply the voltage to obtain the energy in joules. In this case, a single AA battery has an energy of 5,940 joules. In solving problems, always follow the sequence. Convert capacity, apply the formula, and express the answer in joules. However, be careful with the units, especially converting hours into seconds. Now, let's consider this battery. We are going to calculate for the energy produced by this battery. We're just going to apply the formula and the sequence. In this case, the battery contains 11.1 volts and 4,400 milliampere hours. Again, the first step is to convert the milliampere hours into ampere hour, followed by the conversion of your hour into seconds. And multiplying all of the numerical numbers here, we are given 175,824 joules. For these types of problem, please complete the calculations carefully, ensuring all units are consistent. And these types of problem commonly appears in the exams, so accuracy in conversion is essential. Now let's consider the battery here. We are given 12 volts and 200 ampere hours. Since the units is already in amperes, we only have to convert the hours into seconds. And multiplying all the values here give us an energy of 8,640,000 joules. To summarize, battery voltage determines the energy per charge, while capacity determines how long energy can be supplied. Energy is the combination of both. That concludes the lecture on energy generated from the batteries. And please focus on unit conversion and the relationship between voltage, current, and time when solving problems.